Hello everyone, myself Vinay Kumaram. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually discussing the structure of the atom, which is the 4th chapter of 9th standard science subject. So here, now I'll be discussing the chapter 7, which is related to the motion. So what do you mean by motion? So we all know that when we see the world, everything in the world, sometimes they are in motion and sometimes they are at rest. So for example, birds fly, and we also know that cars move, and also we know that we also walk on this particular planet Earth, and we also see so many objects which are there around us move every day. So we also know in our previous chapter we learnt that inside an atom there will be a positively charged nucleus, and around that electrons are moving. So here electrons are also in motion, and also when you consider liquid state or gaseous state molecules, we have studied that in our previous chapter that the particles which are there in the liquid state and the gaseous state will be moving randomly throughout the provided boundaries. So even in solid state, there will be slight amount of vibrations in their mean positions of the particles which are present in solid objects as well. So that means everything which we see around us, to certain degree, there is motion in them. So what do you mean by motion? Generally, in a broad sense, we can tell that if a particular object changes its position with the time. So even if you consider planets, even if you consider galaxies, even if you consider stars, even if you consider this universe, everything is in a motion. So now you can see that seasons, what we are experiencing in an year, are changing. So we will be having summer season, after that we'll be having rainy season, after that we'll be having winter season. So why this season is changing? And we also see that sun rises in the east and sets in the west. So by observing all these kind of phenomena which is happening in our day-to-day life, we can tell that either sun or the earth is in motion. So after so many experimental observations, we have come to a conclusion that sun is at the center of the solar system and all the planets are moving around the sun in an elliptical orbit. So similarly, earth is also moving around the sun in an elliptical orbit. Hence, there is seasonal change. So similarly, when you sit in a bus or when you sit in a train, so let's say you are sitting in a train A. So let's assume this is train A and train A is moving in this particular direction. And let's assume this is train B and this particular train B is at rest. It is not moving. So the passenger who are sitting in this particular train will notice that this particular train is moving in this direction. So is this particular train is really moving? No, it is not moving. It is at rest. And this particular train is actually moving. Even sometimes while traveling in a bus or in a train, we all see that trees and all other objects which are there around that particular vehicle will be moving backward. So is it true that all the objects which are there around that particular vehicle are moving backward? No, they are not moving. They are actually stationary. Your bus, your vehicle is actually moving forward. So in motion, one object can displace from one of its position to the other position in a period of time. This particular change in time, one particular object has displaced from one position to the other position. That means this object has undergone motion. So it might have followed a straight line, or it might have followed an irregular path to reach this position, or it might have followed circular path to reach this particular position. While following the same circular path, it might come to its initial position as well. So it might have followed any kind of path. So all these topics where particle moving in a straight line or particle moving in a circular path, all these concepts related to motion we will be learning in this particular chapter. So now, before going into the motion in a straight line, we will understand how to describe this particular motion. Because if we want to experience a particular motion, we should actually describe what is motion. So before describing the motion, we should understand what you mean by origin. So let us assume your house is in this particular position and there is a school here. So this is actually a school, and let's say there is a railway station far from this school. So let's say in the north direction from this particular school, if you travel for 2 kilometers, you will reach this particular railway station. If you are standing here, if someone comes near you and asks you that where is railway station, so at that particular time you will answer, if you move straight north for 2 kilometers from this school, you will reach railway station. So that means here, for that person to reach railway station, he has to change his position from the school to the railway station. So in that change in position, you are considering the school as your reference point. So how did you calculate this particular 2 kilometer distance? So this 2 kilometer distance is the distance between the initial point and the final point where this particular person is reaching. So forget about this particular path and forget about your house as well. So let's just consider the school. From that particular school, you are traveling 2 kilometers north to reach the railway station. So that 2 kilometers is the distance between the school and the railway station. So from this particular position, a person has to change his position from this position to the position which is there in the railway station. So in order to change that position, he has to travel 2 kilometer distance. So there motion comes into picture. That means he has to displace himself from the school towards railway station. So that means here your school will be the reference point. That will be the initial point, the reference point to analyze the motion of that particular person. I'll give one more example. So let's say you are there in a middle of a particular ocean. So let's assume this is the ocean and you are there on a boat in this particular ocean. So now if you look all around you, you will just see blue sky and blue water all around you. You will not see any kind of objects which are there. So that means only you can see the blue sky and only you can see the blue ocean all around you. Now, how will you decide in which particular direction you are moving? Whether you are moving forward or you are moving backward or you are moving to the left or you are moving to the right, you will not notice because everywhere there is just blue ocean around you because you are at the center of the ocean. So that shows you are not having any kind of reference point to analyze the direction of your motion. So if I have to describe a particular motion, then I should have point A and point B. So only when you move from this particular point A to point B, then only I will have an idea, okay, this much amount of distance this particular person on the boat has covered, and all the parameters which are related to motion, I can calculate from that. But now when I don't know what is position A and when I don't know what is position B, then how can I calculate motion? So here the important thing which I am trying to explain you is that you should always require a particular reference. Only when you have that particular reference, then only you will notice that a particular object is in motion. Now let's say after a while in the same ocean, you will see far away from you there will be an island. So now you have a reference point of island. So now you can see this particular island. Now if that island is getting bigger and bigger and bigger, that means you are actually approaching closer and closer to that particular island. So if that particular island is becoming smaller, actually that island is not growing or not reducing. It is not becoming big or it is not becoming small. You are actually going near to it or far from it. So now you have a reference point. So this acts as a reference point for your motion. So by looking at that particular island, you will notice you are moving whether to the left of the island or to the right of the island or towards the island or away from the island. So to understand, to analyze the direction of motion and to analyze the motion, you should actually have a particular reference point. and that particular reference point is known as origin. So only when you have this particular reference point or this particular origin, then only you can define your motion. Then only any kind of motion can be defined. Even when you're traveling in your vehicle, you will experience that you're going in a particular direction by having reference points, reference objects which are there around you. So when you are actually seeing all the objects moving backward, then you will experience that you are in a forward motion. You are going in a particular direction opposite to the objects which are moving backward. Objects are not really moving, they are stationary, but you are actually moving in a particular direction, and those objects around you will act as your reference point to understand your motion. A reference point, a origin, is very important to define a particular motion. So if you are lost in a ocean, if you are lost in the middle of an ocean, you cannot define in which direction you are moving. You cannot define from which position to which position you are actually going, because you don't have any kind of reference point around you. So that's why reference point is very important to analyze a particular motion and to derive the parameters which are involved in a particular motion. So now we will actually discuss the motion along a straight line. So for example, if we have a straight line like this, and let's assume that the object is moving in that particular straight line. So now if this is a particular straight line, so let's assume this is a straight line, and let's assume this point as A and this point as B, and let's assume this point as C, and let's assume this point as D. Now this particular A is 0. Let's call this particular position A as the 0. That is, it will act as the reference point and it will act as the initial point of our experiment. So now this particular A is at 0, and let us say this particular B is at 30 kilometer distance from A, and let us assume this particular C is at 45 kilometer distance from A, and let us assume this particular D is at 60 kilometer from A. So that is, from A to D it is 60 kilometer, and from A to B it is 30 kilometer, and from A to C it is 45 kilometer along this particular straight line which I have drawn here. So now let's assume there is a particle which is there at this particular A position. So now this particular particle will move from position A and it will reach the D position. So let's say it has reached D, and again it has followed the same path in the reverse direction and it has reached the position B. So now if you consider the total distance covered by this particular particle, it will be equal to, so now I am writing total distance traveled. So what is the total distance traveled by this particular particle? It has traveled 60 kilometer to reach the position D, and from D it has followed the opposite direction and it has taken another 30 kilometers to reach this particular position B. So the total distance traveled from this particular point A to D, from D to B, it is equal to 60 kilometer plus, out of the 60 kilometer it has traveled to B. B is 30 kilometer away from A. So that is actually 60 minus 30. 60 minus 30 is 30 kilometer. So the total distance traveled will be 90 kilometer. So now I will introduce a new concept in this particular chapter, that is displacement. So now let us discuss about displacement of this particular same particle. So what do you mean by displacement? Displacement is the shortest distance between two positions which you are actually considering. So always you should remember, displacement is the shortest distance. So what is the shortest distance? So the immediate shortest distance which you can take to reach one particular position from one particular position. So now here, if you consider the same line, same straight line, here if I ask you what is the displacement of this particular particle, where the particle has finally reached, it has reached the position B. Forget about that the particle has went to D and then it has come to B. Here we are just considering the displacement of particle. So now when you see the initial position of particle, it was there at this particular position A. So particle was initially at the position A, and finally the particle has reached this particular B position. That means it has went to D and again came back to B. So that means now the final position of particle is B and the initial position of particle is A. What is the shortest distance between A and B? Shortest distance is not going to D and then coming to B. That is not shortest distance. It will be longest distance because you are actually going to D and then coming to B. But if you consider just the shortest distance, then it is the immediate path from A to B. That is this particular distance. So this is actually the shortest distance between A and B. That is the 30 kilometer distance. So now if I consider displacement, then displacement of this particular object is just 30 kilometer. So displacement is equal to 30 kilometer. So whereas if I consider distance, then distance is actually equal to 90 kilometer because it has went to the position D and then it has come to the position B. That means it has traveled 60 kilometer and then it has traveled 30 kilometer. So total it has traveled 90 kilometer. But when you consider displacement, what is the definition of displacement? Displacement means it has displaced from a particular position. That's it. What do you mean by displacement? You should just see this particular first word which is there in this particular displacement. It is the displace. What do you mean by displace? If a particular object is actually moving from one particular position to other particular position, that means it is actually displacing its position. So that's why this is actually known as displacement. And the only shortest distance which it can actually travel to reach the position B will be the displacement of that particular object. So now here in displacement, you never consider the path followed by an object. So what is the path followed by this particular object? This particular object has started from A and it has moved to D, and from D it is coming back to B. So that is this particular particle from the position A, it is actually moving to position D. So from A it is traveling to D, it is reaching here and again it is actually coming to the position B. So here we doesn't consider this particular path in defining displacement. So always you should remember displacement doesn't depend on the path followed by that particular particle. It only depends on the displacement of position of that particular particle. So what was the initial position? Initial position of this particle was A. And what is the final position of this particle? Final position of this particle is position B. So it might have traveled till D and it might have come to B. That doesn't matter in displacement. In displacement, what matters is only the change in position. It was in the position A, now it is in the position B. That's it. So that's why displacement is just 30 kilometer, even though the total distance traveled by this particular particle is 90 kilometer, the displacement of this particular particle is 30 kilometer only. So now if we come to the second situation, let's say particle's initial position is A and let's say there is one more position here D. This particle will move to the position D and it will come back to position A. So what is the initial and final position of the particle? So initial and final position of the particle is A itself. So that's why here displacement of this particular particle will be 0. So why displacement of particle is 0? Here the initial position of the particle is A and final position of the particle is A. Even though it has traveled a certain amount of distance, still the final position of particle is the same position which was there, which that particular particle was there initially. So that means initial position and final position are same for the particle. Hence the displacement of particle is 0 because it has not displaced from that particular position. Of course it has moved a particular distance. So if you consider distance, then you can say 60 kilometer it has moved to D and 60 kilometer it has traveled back to reach A. So 120 kilometers it has traveled. So the distance which that particular particle has covered is 120 kilometers. So here you should remember distance traveled by this particular particle is 120 kilometer, but displacement of this particle is 0 because it is reaching the initial position itself. That means its initial position and final position are the same. because its initial position and final position is same, this particular particle has not undergone any kind of displacement, hence displacement will be zero. But if you consider the distance traveled by this particle, it has traveled to D and came back to A. That means distance traveled is 120 kilometer, but displacement is 0 kilometer. So this is the difference between displacement and distance. So always you should remember this particular difference between displacement and distance. Here displacement has a particular direction with magnitude, but distance doesn't have a particular direction with magnitude. So here if you consider displacement, there is no displacement at all. If you consider distance, it has traveled 120 kilometer. So this 120 kilometer doesn't have direction because it has moved forward direction and then it has moved backward direction. That means it has changed its direction frequently. For distance, we are just adding the path followed by this particular particle. So that's why we are ignoring the direction of the path followed by this particular particle. So let's say particle is moving from A to D. So if you are actually considering distance, it has followed this particular path and it has reached this particular position. So what do you mean by displacement? Displacement is just the shortest distance. So this particular straight shortest distance which is there from this particular A position to D position can be known as displacement. But if you consider distance, then actually how much kilometer of distance it has traveled from this particular position to this particular position while following that particular path will actually give you how much distance it has traveled. So that is actually the distance. So that's why there you are not considering the direction, but here in displacement you are just following the straight shortest path from position A to B. So that's why here in displacement direction is also there. In the particular direction a particle is displacing. So that's why this particular displacement has direction, and the numerical value which you will actually give is the magnitude of that particular displacement. So for example, if I say 120 kilometer, then 120 kilometer, this 120 is the magnitude, and the direction in which it has traveled is actually given by the displacement, not by the distance. Because here you can see from position A to D, this particular particle has followed this particular path. That means it has followed a very weird path where direction is not properly defined. Here direction is not properly defined, hence here distance doesn't depend on direction, it only depends on the magnitude, like how much distance it has traveled. So it has traveled, let's say, more than 60 kilometers, because if we consider the shortest distance from position A to D is 60 kilometer, it has followed this particular weird path to reach this particular point A to point B, hence it is more than 60 kilometer in distance. But if you consider displacement, it is just 60 kilometer, which is the shortest distance between the position A and B. So that's why if you consider displacement, there is direction and magnitude. That is 60 kilometer is magnitude and direction is positive direction towards the position D. But if you consider distance, there is no proper direction defined. It is going in all random paths possible and it is reaching the position D. That means direction is not defined in distance. So you should actually remember that when you explain distance, in distance direction doesn't matter. So here when you are actually considering distance, direction is not mattered, only magnitude is mattered. So what do you mean by magnitude? Magnitude is the numerical value which you give for that particular distance. So that means it has covered 120 kilometers, or it has covered 60 kilometers, or it has covered 75 kilometers. So whatever numerical value you will give is the distance. And if you are considering displacement, here also you will have a magnitude, but here along with magnitude it is following a particular shortest distance, particular shortest path to reach that particular position. So that's why here direction of displacement is also defined. So in displacement, direction is also defined, that is in a positive direction or in a negative direction, and along with direction magnitude is also defined. So how much magnitude is there? So that is from position A to B, it is 60 kilometer. So that 60 kilometer is magnitude, and that magnitude is in positive direction, because from A to B, if we consider that as positive direction, then B to A will be considered as negative direction. So that means here, if this particular particle moves from A to B position, then this particular direction, if we consider this as positive, this particular direction will be considering as negative. That means particle has moved 60 kilometer in positive direction, and it has moved back to minus 60 kilometer in negative direction. So this particular minus and this particular plus actually defines the direction of motion of this particular particle. So that's why when a particle starts from A and it reaches D and again it comes back to position A, here displacement will actually have direction also. So that means when traveling from A to B, it has plus 60 kilometer, and when it has reached from B to A, it is actually minus 60 kilometer. Of course, it cannot be minus. So here minus and plus are just giving you an idea of direction. That means plus 60 kilometer means it is moving in positive direction towards B, and if it is coming back to A, then it is following a negative direction to reach A. That means it is moving in the opposite direction for the path which that particular particle has covered initially. So that means here negative sign indicates the path followed is opposite to the initial path followed by that particular object. So that's why here plus and minus actually gives you the direction. But whereas if you consider distance, there is no plus and minus, it is always plus only, because it has traveled 60 kilometer and again it has traveled 60 kilometers. So total distance will be 120 kilometer. But if you are considering displacement, then it has moved 60 kilometer positively and then it has moved 60 kilometer negatively. So that means the direction has changed. Yes, of course, there is 120 kilometer of distance traveled, but when you consider displacement, it is 0. Because it has traveled plus 60 kilometer and it has traveled minus 60 kilometer and reached its original position. So that's why the total displacement will be 0. But total distance traveled is 120 kilometer, but the displacement of object, if you are considering, it is plus 60 minus 60, that is 0. So this actually shows you that displacement have a particular direction. So here I have written displacement have a particular direction and magnitude, whereas distance doesn't discuss about direction, it only discuss about the magnitude. That is the numerical value which you are actually giving for that particular distance. So this is all there in this particular video. The further concepts which are there in this particular chapter will be discussed in subsequent videos. So if you want to learn more physics, chemistry and mathematics like this starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.